So in this video we'll just get straight in and start on the control rig. So first of all we'll need to create our joints. So I'll go to skeleton, joint tool, and in the first video the length of my upper arm was 3 units long, so I'll do that here as well. And the lower arm was a length of 4, so I'll make it 4 units as well, and I'll just press return on the keyboard after that. Now I want them positioned and orientated the way that I had them before. So what I'll do very quickly is just go to skeleton, IK handle tool, and create a quick IK handle between them. And then I'm just going to delete the IK handles. Now they're in a position that I want them to be in. However, unfortunately they have some rotation values which I don't want them to have. So what I'm going to do is just go to create locator, and I'm just going to create a locator for every pivot point of the bones, or the joints I should say. There we go. Now I can just delete that original chain and just create a new one. And you'll notice now it has a translation value of 3 and no rotation. And this has a translation value of 4 and no rotation as well. And that's exactly what I want. So now what I'll do is I'll just open up my outliner. Actually, I'll use it here. And I'll just begin to rename some of my objects. So this is going to be the upper arm, lower arm, and wrist. We can actually keep these locator objects. So this is just going to be the upper arm lock for locator. This is going to be the elbow lock. The last one is going to be the wrist lock. We're also going to set things up so that the rig can be globally scaled. To do this we need some sort of root object, a root node, and it can be anything really. So what I'm going to use is just a cube. So I'll go to create polygon primitives, and with interactive creation off I'll just click on cube, and I'll rename this as root. I'll create another locator, and this one is going to be called soft blend lock, and I don't want to restart my computer. And I'm going to position this at the wrist, and this soft blend locator is what is going to allow us to blend between stretchy and non-stretchy soft IK. So now that we have that, we need to prematurely create some object to control our IK handle. So I'm going to use a circular nurbs curve. Align that to the wrist, and I'll call that arm control. And what I want to do is just go into component mode and rotate these CVs around with discrete rotation on 90 degrees, just so it's a little easier to select. And I'll come out of component mode now. I'll create one more locator. This locator is going to be called arm control dist lock, and we're going to be using this locator in some of our distance calculations. So now we have most of the objects created. The only thing we need to create now is some distance measuring objects, but that's pretty much it for all the joints and locators. So now we can do some parenting, I should say. So what I'll do is I'll select my upper arm and my wrist point, and I'll parent that to the upper arm locator. Now what I want to do is set the upper arm, elbow, the soft blend locator, and the arm control and parent that to the root. Finally, what I want to do is parent the arm control distance locator to the arm control. So now we're in a position to create our IK. Before I do that, I'm just going to increase the size of these joints to 2, just to make them a bit easier to see. So I'll go to Skeleton, IK Handle tool, and you can see I'm using an RP solver. And I'll just create that from the upper arm to the wrist. I'll call this arm IK, and I'll select the elbow locator, then the arm IK, and I'm going to do a pull vector constraint here. So now when we select this and move it, you can see we're controlling the elbow there. And also what we need to do is select the arm IK and link that to the soft blend locator. So it's quite a lot of setup, but hopefully you're following along. So now we're in a position to add some attributes to our arm control. So first of all, I'll just freeze the transformations. We can also delete our history, and I'll lock and hide all the attributes below translation. So now let's go to Edit, Add Attribute. And I'll call our first one IK Controls. I'll override the nice name just so I can capitalize that K. And this is just going to be set to displayable. And I'll just say Add. Now I'll add a slide parameter or slide attribute, and I'll just remove the P in the nice name, and it's going to go from -1 to 1 with a default of 0. Next one is stretch P. Again, I'll just remove the P. It's going to have a minimum of 0, maximum of 1, and a default of 0. Add our soft P. This is going to be the same, so 0, 1, 0. You see, add there. And lastly, pin P, and again we'll just remove the P. And 0, 1, 0, and press OK. Okay. Now what we have to do is create an aim constraint from the upper arm locator to the arm control. What this is going to allow us to do is blend between our stretchy and non-stretchy soft IK. So if you see the arm control up here, as I start to move the upper arm locator here, as I start to move the arm control, you can see it's looking at it there. So this is essential in our setup. So I'll say, first of all we have to select the arm control, then the upper arm locator, constraint, aim constraint, and I'll just reset this. And we want the aim vector along the x-axis, so that's fine. The up vector of y is obviously fine, but I'm going to change the world up type from vector to object rotation up, and this allows you to use another object to influence the rotation of the object that you're applying the constraint to. And the world up vector is fine here because we're going to use the root for this. Okay, and then we'll just say add. So now when we select our root and rotate, everything is still fine. At the moment we can scale everything and everything is fine as well. The last thing we have to do before we jump into the node editor is we have to measure some distances between our objects. So I'm going to say create measure tools, distance tool. I'll just create them up here, and I'm going to call this one control dist. And the reason I'm creating that up here is because I'm going to use mel to reassign the start and end points of the actual distance. The reason for that is because we have multiple locators overlapping here, so I just want to make absolutely sure that I connect to the right ones. This is going to be soft dist. So control dist is going to measure the distance between the upper arm locator and that arm control distance locator. The soft distance is going to measure the distance between the soft blend point and our wrist point, I think. Yes, that's right. Next one we'll create. This is going to measure the upper arm distance, which is just the distance here. I could have created it here because we've got two locators on their own, but I'll just do it all the way like this. Next one's going to be the lower arm dist. And finally we'll have one called stretch dist. Okay, so let's open up our editor here, script editor, and you can see I've already typed out what we're going to do. So we're going to connect the upper arm for the control dist. This is just what I was saying a few moments ago. We're going to connect the upper arm locator to the start point of the control distance, and the end point is going to be the arm control distance locator, and we're going to do that for some other ones. So we'll just highlight all of this and press return on our keyboard. And we don't have a, oh, I've got a capital I here. So let's see, do this one again, and that's fine now. So you can see now it's done all of that because all of our locators are now on their own. So we can just delete all of them, and now we have everything set up the way that we want it to be set up. Okay, so now we're going to jump into the node editor. So I'll say window, node editor. Before we actually get started, I'll actually show you what it is that we're actually going to create. Like I mentioned in the first video, I did this with expressions first of all. So I have the expression here. So this is what we're going to be, if we were doing this with expressions, this is what we're going to do here. But now we're going to try and do it with nodes instead. So you can see we have an if statement here, so we're going to need a conditional node. We have another one here, so we're going to need nested conditional nodes. We have an exponential here as well. And we have several plus minuses and division and multiplication, so we'll need those nodes as well. So let's start off with the if statement. So let's get the condition in there. Now let's see if I can do this. So we want the control dist, which is just the control distance shape.distance, and that has to be greater than the chain length, which is 7, remember, because that's the way I set up the bone chain, and the soft p, that's just the parameter applied to the arm control. So let's get them in. So control distance, we'll go to display, shapes because we want the actual shape, not the object itself. So there it is there. Now we'll need to get in the arm control because we need that soft P value there. And now we can get started. So the first thing we need, if I refer back to this again, we need to have a greater than, and this has to be some sort of sum or subtraction, in fact. So that's what we need. So we're going to go to plus minus average, and I want to put it into the 1D here. Unfortunately, there's nothing there, and we can't put in just numeric values here. So what I can do is say, just down here, set attr plus minus average 1 dot input 1d 0, and let's put in the chain length, so that's going to be 7, and just return that. And now you can see it works. And let's just put in another one as well, and I will just call that 7 just for now. And you can see another channel comes up here. So now what we can do is actually put in our soft value here. And like I was mentioning, we want subtraction. So let's check. There's the chain length is 7 minus soft P, which is put in there. That's fine. And now we want to put that as a greater than, and we want the distance to be placed into the first term. So if this is greater than this, then we want something to happen. Now we're going to need another a nested if statement here, and you'll notice that I don't have an else statement here, because what really we want to return is this soft distance. So I've defined the soft distance up here, just that we don't need an else statement down here. So what we're going to do is place the control distance into the output if it's false. Let's just expand this. So now what we have to do is deal with color if true, and that's this section, and we need a nested if statement. And the reason for this is because basically that we're going to sometimes we might divide by 0, and that can cause an error. So we need to remove that case. So we need to break this apart. So if the soft parameter is greater than 0, do this, else do this. And you can see it's interesting, you don't need this in MaxScript, but you need it in Maya, because if soft P is equal to 0, we're multiplying 0 by some expression, so you think that this would all be 0, but in Maya it still causes an error, so that's why we need this. So we're saying chain len down here. So you'd think that when we multiplied all this by 0, we just get the chain len, and that's what we're saying down here. Okay, so we need another condition, and this is going to be if soft in the first term is greater than 0, then do something, else return the chain length here, and the chain length again is 7. So color if false we can put in 7, but now we're going to have to try and build up this large equation here. So we'll start by building up the chain length minus the soft P, which actually we have here, so that's kind of convenient. So what we need is a plus minus average, and what we can do is, if I just say output there and then remove that, and then put it in there and then remove that, it's given us our two channels. So we want this to be a subtract, and the first one, again, I'll bring this over, is the control distance, and we want that to be minus the actual first node we have here. So this one is going to go into the second circle here, and this is going to go into the first one here. Okay, next what we need is a multiply divide node, and this is going to be for this section here, divide by the soft P. So we're going to divide what we've just done by the soft P value. So we set this divide, get our soft value, and there. Okay, and this is becoming quite messy quite fast, so let's just see if we can lay this out a bit nicer. I think the answer is no. Now what we need, we've done this, this, and this. We need to multiply it by -1. So -1. And now you can see it's encountered division by 0, result is unpredictable, and that's exactly why we're having to do this. So now we've got all of this term inside the exponential function. Now an exponential function, we can get that if we just say exp1 and then return that, and we can use this value as our exponential function. So I'll just say apply divide. Let's find it here. Just copy that. Change this to power. Paste that in there. It looks as though it's giving you a rounding error, but the value is stored in there. X. I've lost my, where is it? Yeah, here we go. So now we've set up this. We need to multiply it by soft P. And the last thing we need to do is subtract our equation, or part of the equation, from the chain length, and that's 7. So we'll need a plus minus average node for that. And I'll just place it in there, drag it away, and we can place that one in there. And this has to be a subtract, and it's 7 is the chain length. So now finally what we can do is put this into our color if true. Oops, I got the wrong one there. Okay, now we can bring this down and output our color R into color of true R here. And at this point what I'm going to do is just lay out the graph. Collapse that and just lay out again. And we want this result to be placed in the wrist point. So let's find that. Wrist, let's get rid of our shapes here. Arm, wrist locator, here we go. So we'll just middle mouse button drag that in here. Out color R, we'll place that in the translate X. So now you can see it's following along up until 7, and then it's no longer following. And we can move this back, everything's fine. And now if we put on a soft value of say 0.2, actually let's make this easier to see. There's the soft IK. Okay, I'm going to stop the video here. In the next video we'll just continue on adding some extra features. Thank you.